Good morning, everyone. Welcome to the webinar. I just would like to announce that we're recording this webinar, so please be aware of that. I think we have an opening introduction talk by Albert Seubers from Martel. The EU has a wide range of funding initiatives to fund cloud innovation. And one of them is cognitive cloud, for example. Many innovations are being developed throughout the consortia in Europe, and we would like to report out on what those innovations are and how they contribute to the European cloud scene. We've invited 7 projects from the various programs. They're going to report out on what they're doing, for which use cases they see their innovations very valuable. And we're going to specifically focus on 3 questions in the webinar. One is, what types of AI are appropriate for cognitive cloud innovation? So what type of AI are we basically addressing? Which ones do we see very relevant? Then there's another question that goes around, which is AI needs to be trained, deployed, and managed within a cognitive cloud. How do we make it lightweight, flexible, and basically easy to use? And the third question is geared towards the future, is where we want to look at all the various innovations that we're doing. And we've met with some of the other projects as well. And we're asking ourselves now, basically, so what's the next wave of innovation that we need? Because these kind of projects were basically the starting point of innovation around cloud, but we need to continue innovate further. Your limelight, so please go ahead and share your slides.
Thank you, Fred. I will. I hope you can see my screen.
Yes.
Perfect. Thank you. Well, thank you for inviting me to do the short presentation and introduction to the EU Cloud-Edge-IoT initiative. As a coordinator of Open Continuum, I'm happy to do so. The EU Cloud-Edge-IoT initiative is based on joint forces of 2 CSAs. One is the Open Continuum set, and the other one is Unlock CI. The difference between the two is that Open Continuum is focusing on the supply side of the continuum, where Unlock has focused on the demand side. So we're trying to match these demands and to see how we can support the community of research projects focusing on Cloud-Edge IoT. So the focus is several objectives: promote an open ecosystem. So this is the collaboration part, and open source, open standards. We're trying to support the RIAs as much as possible to work with open source and to contribute to open standards. Open standards is not always easy. RIAs have a limited time frame, and creating standards takes a lot of time. But we try to do this at best. 28th of May, there's an IEEE event in Helsinki where some of the project will be presented. And from Open Continuum, we work on a joint taxonomy and a reference architecture to support this. That's part of the standardization that we will present there. Unlock is working on market scenarios, shareholder, stakeholder engagement. So building communities supported by this should support. So these 2 elements together have created joint task forces that we invite all projects to participate in, join them. So from Open Continuum, we have a constructive work collaboration with research initiatives, EU initiatives with the industry sectors, IoTI, Gaia-X, KDT, SNS joint undertaking. And there's a lot of events that we participate in representing the projects. So if you would like to be presented at some of the events, please connect to Task Force 1. Katrina can help you in this. The second task force, Eclipse, is running this, is on open source. And then we have the architecture task force on the taxonomy and the reference architecture that will be published soon. It's the first presentation now done to the EC. Of course, you can imagine there's always requests for more details, but this is what we work on and finish by the end of the project and hand over to the next CSA to support the RIAs in a continuous way. So then there's two on the open calls and the demand market drivers, where we have the value chain adapters working group there as well. And then the sixth task force is what we supported by today is the communication task force, the series of webinars that we are organizing, and brand and community management. So the community, as said, is growing. Some of the projects mentioned here have finished already. Some of them just started. But we can imagine the EC is really interested in building the stack from RISC-V, that's not in this, but we invite them where we can, up to MateOS, Swarm, Cognitive Cloud, and build that stack and how to contribute. So all these projects are contributed to this, and there should be, by request of Max Lemke, by the end of June, the first report on how these collaborate together and supporting the industry. So that's where we need your input, and this is also where we can support you in disseminating this type of results to the EC. Now, today's webinar is part of a series of webinars that we are organizing. Katrina is leading this, so we had already IoT Insights, we had the MateOS, Cognitive Cloud, is done today, is a future-proof solution for cognitive-enabled cloud computing, part one of two events on the same topic. There's a few more coming. Swarm and open source is happening soon as well. So reach out to the EU Cloud-Edge-IoT website, RIA Showcase, as mentioned here above, to register for it. And if there's any questions you have regarding organization of a showcase webinar in this, please reach out to Katarina. Thank you for the introduction here, for allowing me to do the introduction, and I wish you a very solid and fruitful webinar. Right.
Thank you very much, Albert, also for the very nice overview. Let's dive into the projects that we have. I will share some slides.
Okay, so hi everyone. So I'm Ruth Sofia. I lead the Codeco project, which is one of the mentioned projects in the cognitive continuum. Next slide, please. And so today I will give you a quick overview on Codeco and then focus more on the topic of the webinar, which relates to the use of AI in Codeco. So Codeco is, similarly to other projects in this topic, an orchestration framework. So this means a management framework for containerized applications across edge and cloud, whereas edge means the far edge. And so the vision is that across Cloud-Edge-IoT, we have applications being deployed based on architectures of, so microservice architecture, so containerized components of applications. And currently they can be deployed, as we know, not just on the cloud, but actually with some freedom. Normally, they are deployed across near edge to cloud, but more and more, as we all know, the applications are being deployed, or parts of the applications are being deployed closer to the data sources. And so the vision that Codeco has is that these environments are becoming more complex, large scale, and mobile, and that implies that we need more flexible orchestration tools. Next slide, please. Next slide. Thank you. So in terms of Codeco, so then what are we exactly building? We are building an open source framework. So you have the link for the existing code there. Codeco right now has 14 months of life, I believe. And in June, we will release the first open source framework complete. So right now, what you have is components. I will show you in the next slide. But there are other things that we are doing similarly to the other projects. So we are building 6 use cases that use Codeco to manage different types of applications. So this is not management of AI, but actually using AI to orchestrate IoT applications across the far edge to cloud on different environments, for instance, digital twinning or manufacturing, so AGV fleets. So that's the main goal. And of course, we have other assets, as you can see on this slide. Next slide, please. And so what exactly does this framework has? So on the left-hand side, I hope you can see the components of Codeco. So you see the interface to the user. We call it ACM. So in fact, this is, so one of the things I did not mention is that as orchestration tool, Codeco is a framework that is pluggable to Kubernetes. So that's our decision to implement in an agile way an approach that would rely on AI and be flexible enough to do this deployment. And so this means that each of the boxes that you see on the left-hand side is actually a component. On the right-hand side, you have the names. And these components, they do different things. So ACM is basically, as I said, the control plane, so the management plane, and is actually based on an existing open source Red Hat tool, OCM. And then we have a new scheduler based on this seamless workload migration. So in other words, other components of Codeco can be used with a Kubernetes scheduler, but we also have a more interesting scheduler that uses a new approach, who uses a graph-based approach to do the deployment of the applications, not a filter and score approach as Kubernetes does. And we have NetMA, which is, let's say, a component that brings network awareness to the orchestration, which is something that we don't have. So the orchestration that we have today in terms of application deployment relates with computational resources, so node resources. And so NetMA integrates network awareness. What is the status of the infrastructure? How are the nodes connected, etc. And the AI part resides, so the core, let's say the orchestrator, the brain, is actually PDLC. So it's another component that can be used alone or together with the other components of Codeco. So where do we use AI then and why? We use AI to provide estimates on the, let's say, infrastructure. So this so-called edge to cloud IoT infrastructure relates to us. The vision is that it's not just a set of nodes, a graph, it's actually the nodes, the links between the nodes, and also the data workflow. So one component that you see also there is the metadata manager, which creates an observation of how the data is flowing across the Cloud-Edge-IoT infrastructure. So I said infrastructure to us is network data compute. And so that's also a new approach that Codeco brings. And we use AI not to do the deployment. So in fact, the decision to do a deployment of the application is actually on our new scheduler, so this SWM. But actually AI passes an estimation to SWM, and SWM takes that into consideration when doing the application deployment. So why do we use that? Because, for instance, if we think about, let's say, a Cloud-Edge-IoT environment, which is mobile and where nodes are mobile, it may happen that SWM, so a scheduler, decides to do so an application right now, an application deployment, and in a couple of seconds or minutes, there is a node that moves, and so this selection, this instantaneous selection, was not necessarily the best, taking into consideration history of the system or of the infrastructure. And so that's where AI enters. So that's one of the parts that we use AI. And another part is, of course, to do an estimation of the use of the resources. So this means, for instance, at a node level, this means CPU, memory. So what is the status? At a network level, this means, for instance, bandwidth, energy consumption. So transmission, how much energy are we using? And at the data level, this means data observability. For instance, what is the freshness of the data? Is the database of an application growing too much? And we need to do something about it. So in terms of which AI do we use right now, so Codeco is the first phase of Codeco, so first 18 months is deployed to build all these components and to validate and test them in a single cluster infrastructure, which is something a little bit easier. So the next phase, which starts in July, relates with federated clusters. And we use AI, so in this orchestration, okay, right now, for the single cluster, we are studying approaches that can be extended towards decentralization. But of course, in a cluster, we don't necessarily need decentralization. We can apply federated learning. So what we are using right now to do this estimation and to pass it to the scheduler is reinforced learning, okay? And then with a specific reward function based on outputs that the scheduler gives. And for instance, for the let's say for the analysis and estimate of usage, we use GNNs. And for the next phase, for the centralization, we are analyzing swarm learning. So that's one of so for the federated cluster operation, we expect to use Marl or swarm learning. Next slide, please. So this is my last slide. So here you have a link for the current architectural status. If you want to check, there is also code that you can download for this part of PDLC, which you can test. How do we use so the models, the training, etc. And basically, you have a summary also on why we use AI. So I explained what we use, and here why we use AI. Thank you.
Thank you very much, Rutte. That was a very interesting presentation, and very rich in the amount of AI that you're using across the whole architecture. Are there any questions from any other members, or shall we reserve the questions to after all the presentations? Yeah, shall we do that? Okay, then we go to the next project, Edgeless. Please, Claudio Cicconetti, would you please present your project?
Yes, with pleasure. I thank the organizer for the kind invitation. I have the honor of being the technical manager of the project. Next slide, please. So the ambition of our project is to enable low-code development of application, which will be then deployed and managed efficiently and in a secure manner in the Edge Cloud Continuum. So yeah, at this high level, I guess there are many things in common with all the projects in which will also with Codeco and the other projects which we'll present later. So let me explain a bit what we mean in particular. So by low code, we are focusing on the stateful function as a service concept. So in Edgeless, as the name sort of implies, we want to adopt the good things about serverless computing, which are mainly the flexibility in the orchestration and runtime scheduling of resources, the fine-grained granularity with which you can load balance and also bill about the use of the resources, etc. But we want to make this stateful, because as it is well known, most serverless computing platforms are stateless the applications, because this is so much easier. In our case, we want to add the state because we need the state for the AI applications, which makes the overall approach AI friendly, as will be demonstrated in our use cases. So the applications in our case are mostly AI tasks. For the deployment, we target at having automated processes for continuous integration and continuous development. Efficient here means, again, to use AI in this case for decision making and for anomaly detection, which is something which AI appears to be good at. Secure, with secure, we want to exploit the technology that enables applications to run in a trustful environment, such as using trusted execution environments or trusted platform modules, which are available not only in the cloud, but also in our edge nodes, where the edge for us, like for Codeco, is the far edge. So we are targeting resource-constrained devices, which are unreliable, which can be mobile, which can have very limited resources, and that might have specialized hardware. Where specialized in this case, you might guess, is for the execution of AI tasks. Again, next slide, please. This is the big picture of Edgeless at the moment. I don't think it's a good idea to go into the tiny details of this, but I would like to give you a high overview about the journey that we promise to give the users of Edgeless. So this all starts with the application developer on the top left part, which has an application to deploy, and they can compose this application as a workflow of stateful Lambda functions that interact with one another. This is also called, I think, in the literature, micro agents approach or microactor approach also in some scientific papers. So this workflow, which also has annotations regarding the service level objectives that the application developer wants, and the characteristics of the load that they expect, is given to our controller, which we call epsilon controller, which will then take it to the resources via what we call edges, epsilon orchestrators. So there is one controller for the whole cluster of resources that are managed by a single administrative entities, but this cluster can be split in multiple local domains, where one local domain can be, for instance, the cloud on the bottom right, or an edge computing cluster of nodes in the bottom left part with constrained devices. And it is possible that because of to have the optimal use of resources, some of the functions that are requested by the same user go on one orchestration domain, for instance, Lambda 1 and Lambda 2 in the picture, while Lambda 3 is executed on a cloud node for some reason, which is selected at runtime by a joint operation at the epsilon controller and the epsilon orchestrators. And we also foresee the existence of multiple clusters where you have a multi-provider system, which will have to happen via the definition of suitable multi-provider contracts on the top of the picture. To enable the continuous integration, continuous development pipeline, we have on the right the funcdev, which is the function developer in our terminology, which creates those functions and pushes the code to a code repository, which is automatically built into binaries that can be executed on the multiple types of hardware our cluster consists of, into a function repository, which is then used by the different elements of the system, so that it is possible to deploy, if this makes sense at all, one function on a Raspberry Pi device, another and on an NVIDIA embedded device, or in a container inside a cloud node in the public cloud. Where is the AI? The AI is in two places. So one place is in the optimized execution of the system, so in the SLA management and in the runtime orchestration that is done by the epsilon orchestrators. And we want to use AI in order to capture all those dynamics that are difficult to guess if you want to yes, I'll wrap up soon. If you want to do a good job in the orchestration, and we have AI at the application level. So the AI runs inside these Lambda functions, which can be AI tasks. Next slide, please. We have three use cases. I didn't bring many details for that, but I just mentioned them briefly. We have an advanced multi-surveillance, where the AI tasks consist mostly in the detection of object and of context situations based on computer vision. We have an Internet of Robotic Things, where the AI tasks are used both for acquiring the context about the environment of a movable robot, and for the acquisition of natural language processing if we have the human in the loop. And the healthcare assistance use case, where the AI consists of human activity recognition and similar tasks that might happen within a customer house. And that's it.
Thank you very much, Claudio. Very interesting. Another very good example of using AI across the whole edge to cloud continuum. Let's move on to the ENACT project. Alexandros.
Hello, I'm Alexandros Nizamis from Center of Research and Technology Hellas that coordinates ENACT project. ENACT project is focusing on adaptive scheduling and deployment of data-intensive workloads and targeting energy efficient from edge to cloud. Please move to the next slide. The project has started this year, is under the topic related to cognitive compute continuum. So we are now in the month 4 of the project. We have 16 partners coming from 9 countries. We have some leading European institutes. We have 2 large companies such as Siemens and Fujitsu, and also 9 European SMEs. Our pilots here are based on media distribution and the improvement of user experience based on Cloud-Edge technologies. So Moog Technologies company and SPTD provide this type of pilots here, and we have also Fujitsu that is our 3rd pilot, and we have a digital twin related to mobility for the Tokyo city, and we're going to apply also our Cloud-Edge technology there as well. Move to next, please. So this is our main concept and our main objective, let's say. First of all, is to develop technologies that will enable us to realize a cognitive compute continuum that can address the needs for optimal deployment of the resources, to provide dynamic scaling, elasticity, portability for this kind of hyper-distributed applications, as I described so far. So what we are aiming to deliver here is to provide various tools that will enable us to connect and discover the various distributed resources that we will have in the pilot cases that I have just described. Our core AI part is the AI-powered orchestrator that will combine different kinds of technologies, as I will explain in a minute. And also we are aiming to provide an application programming model and an associated software development kit for this model. The idea is to have some kind of portable applications that can be configurable in a different way if we're going to deploy them on cloud or if we're going to deploy them on edge. In our main concept here, we have a graph-based approach. We're going to create a graph of resources. Then the idea is to try to get this information of this graph and instantiate some kind of GNN models and try to combine them with reinforcement learning agents. So the GNN models and the created graph will provide us a kind of the topology. We will have some kind of AI forecasting as well that will let us know for some cases and simulations that we can get based on the current state of the compute continuum and the deployment that we're planning. And after that, we are going to combine them with RL that we will try to use this kind of information as the goals that they will try to optimize. So based on the graph that has been created and this AI forecasting and prediction, we will try to run this RL agent to optimize this kind of goals. So this is our main concept regarding the AI. So we have a kind of combination of technologies near to what we see in the first presentation from Ruth and Codeco, I think. So it will be nice to see how we can do some stuff in parallel and check any kind of synergies and so on. And I think that's it for me. As I said, we are in the beginning of the project. So this is the high-level information for us now, and we are on the design phase of the project. And
okay, thank you.
And you can see more info from us in the next slide that we have our website, social media, and so on.
Yeah.
So thank you.
Thank you very much, Alexandros. We will talk later more also about some of the challenges in your project. Let's move on to Intent project. Hui Song, would you please present?
Yes, my pleasure. Thanks a lot for inviting us to this event. It's very exciting to see many interesting things happening in other projects. I can already see a lot of interesting collaborations that could happen in the coming years. So I'm also looking forward to this kind of events later on to have more collaboration with each other. So I'd like to introduce briefly our project called the Intent. The full name is Intent-Based Data Operation in the Cognitive Computing Continuum. You can see the 16 partners in the below. We have large companies and universities from 9 different European countries. plus 3 partners from the South Korea. Please, next slide. So first, our project is kind of relatively young. We start together with ENACT, I think, so only a few months old now. Also, interestingly, that we start in a slightly different time. Before we, so it's a time that the AI has been developing very fast, and we start to see AI behave more like a human in many different areas. Like they can talk, they can write poems, they can draw, they can even sing. So we had the similar question: is it possible that the cognitive cloud could be a bit more advanced with similar kind of intelligence like a human? And we specialize this requirement into 3 directions that are relevant in this context of cognitive cloud. So we believe first that the cognitive cloud should be able to adapt like a human. They should continuously learn how to handle the different situations and different type of resources without having the pre-defined knowledge or experience about what the resources are and what the data are like. And then since a continuum is a composition of many distributed resources, then the decision, whatever decision that was made by the AI should be somehow strategic, even if maybe each special part of AI agent will only have some localized knowledge. And last but not the least, we want the AI to be able to talk to the human, to understand what the human stakeholders really want about the continuum and about the data pipelines running in the continuum. And at the same time, they should be able to explain to the users what and why and how they make certain decisions in order to create the trust between the AI and the human. So we want to explore these technologies to eventually achieve what we call the intent-based data operation. And we want to apply this in 5 use cases, which I'm sorry that I didn't have space to put them into the slide. So we have a use case on the application side to look at the green video distribution in the internet, and also on the machine data analysis. We have also use case on the infrastructure side, trying to see how to use the 5G infrastructure as a data processing platform, and also how to support the platform beneath the data space. And finally, we have a use case, experimental use case, looking at the robotics, how the data flow through many distributed robots. I also have a slide trying to explain the technology. If you could turn to the next one. I think this would also answer the questions about what types of AI we plan to use. So if you look at the very bottom of the continuum, so we consider a continuum as a composition of many resource domains from the public cloud all the way to the edge devices. And we have the data pipelines flowing through these resources. And please, it's not next slide, but there's some animation. If you click, I should probably see something more popping up. Yes. So the first step would be to use some agents to manage the data pipelines and the resources within the resource domains. This is a typical problem for data orchestration and data storage management, network management, for example. And we have partners who have already looking at using AI to solve these problems in a more intelligent way. And we further challenge them to do this in a more continuous way, to be able to continually learning what resources are available in the system and how to manage the resources in a more efficient way. So here is mainly the traditional machine learning or deep learning techniques, but with more reinforcement and continual learning flavor there. And on top of this, if you could click again, we consider that these agents need to collaborate or need to be coordinated. And here, this is a problem, open problem of decentralized intelligence. When trying to learn from theory explaining how our brain works in a decentralized way, there's a theory called the global workspace theory, which coordinate multiple agents with local knowledges and try to make them to work in a strategic way. And we do it in a similar way, and with the support of how to measure the end-to-end security and the trustworthiness of data pipelines through multiple resources. And finally, the last pillar of the work, yes, there should be the next click. Now we're talking about how to make all these agents and the coordinators to talk to the human stakeholders. Here we will exploit the generative AI, especially the large language model, to interpret the human intents into low-level commands in order to talk to the agents, and on the way back to explain how these agents make certain decisions. And these will put together into a chatbot based on the knowledge graph of all the continuum and the user preferences. So I hope this could briefly explain what AI we would like to try in this project. And I'm ready for a further discussion in the next sessions.
Thank you very much. Thank you, Mr. Song. We move on to the next project, Cognet, and Georgios Spanos will present it.
Hello, everyone. I am Georgios Spanos from Center for Research and Technology, ELAS. CERT is coordinating the cognets, continuums of game nets, short intelligence as information processing. This is a project that has 36 months duration, but has not officially started yet. We are in the GA preparation. Please go to the next slide. Okay, some introduction to the Cognets project. The ambition of Cognets is to develop a middleware framework that is able to empower IoT to cloud devices in order to organizing autonomously with dynamic IoT to cloud swarm continuums for optimal data processing and seamless service provisioning, following a specific approach, which is the on-demand opportunistic approach based on asymmetric multiplayer competitive games. Asymmetric multiplayer competitive games is a core proposal of Cognets. Essentially is an extension of the swarm intelligence in order to contain the self-organization in terms of pricing, bidding, and auctioning. We can have the chance to discuss a little bit more after that in our session about AI. Please click in order to. Yes, I think, okay, yes. In my presentation, it was a little bit different, but okay.
No problem.
Of course. Our consortium comprises 5 big industries, 6 innovative SMEs, 5 research and technology organizations. One of these organizations is ours. And finally, 5 universities. And of course, in the map, we can see the different countries that compose this consortium. So, what are the main objectives of Cognets? The first one is to build intelligent game agents that can enable self-organization at the edge level. Here we have the devices, using feature-based heterogeneity models and asymmetric competitive games, as I said previously, with this new technology. The second one, of course, is to develop a middleware framework in order to orchestrate dynamic IoT to cloud swarms. of autonomous data processing using also analytical model distribution and the localized federated multi-context. The third objective is related to security, is to build an end-to-end security for addressing specific swarm-centric threats on all levels, from IoT to cloud. The fourth objective is about the collaborative federated learning, and also we have here another aspect of AI technology by improving the AI service response locally, while of course exploiting the whole chain edge to cloud to assist in accuracy and using also AI pruning technologies that we can discuss later. The fifth objective is about the testbed deployment that we plan to develop in our project to validate proof of concept of the proposal of the cognates. And finally, of course, the final objective is about to identify the different European Union social, ethical, legal, and other aspects of the cognates and ensure its promotion to all the communication channels related to computing continuum, cognitive cloud, etc. And if you click one more, yes. Here in this figure, we can see first of all the three different use cases that we will pilot the cognates project. The first one is about the manufacturing and the connected industries. The second one is about the automation and the the Internet of Vehicles, the connected vehicles. And the third one is about health and the connected healthcare organization. We can see in this figure the three different aspects of computing, energy, and security, and the main concept of these game agents that give the opportunity to the devices to self-organize, and also including these three main properties of pricing, bidding, and auctioning. Okay. Of course, this is the main presentation from me. As I said previously, the project has not officially started. Of course, all this information comes from the proposal. We don't have until now our kickoff meeting.
Georgios,
yes,
may I ask a question? So yes. The swarm, of course, is also each agent. It creates some swarm is also some intelligence, swarm intelligence.
Of course.
But around that swarm intelligence, are you using any other form of AI or ML to feed the swarm, or to control the swarm, or to monitor the swarm?
Yes, in order to monitor the swarm, the main AI technology that we will use, because the project has not started, is based on asymmetric multiplayer competitive games. So the orchestration of the swarm intelligence will be enhanced by this AI technique of asymmetric multiplayer competitive games.
Okay. Interesting.
But of course, I can elaborate more later in the open discussion about the technologies.
Yeah, perfect. Thank you very much. Then we move on from.
And these are our contact details. I am Georgios Panos, and the project coordinator is Konstantinos Votis, and our emails can be shown here. Thank you.
Thank you, Georgios. Thank you very much for the interesting presentation. So we go from cognit to. I have a different slide in the listing. I have a different one. But okay, we go to Wami, to Marco Mancini.
No, this is cognit. It's the point that I sent you a slide also about myself.
For cognit.
Yeah, it's for Cognit is the project, right? I sent you just a slide about myself, but I am from Open Nebula, and Open Nebula is the coordinator of you can go to on the second slide. It's the coordinator of the Cognit project, not Cognit with the I. That has been funded now by the European Commission under the topic of Cognit Cloud. So the project started in 1st January of 2023 and is finishing in by the end of the 2025 year. So it's a 36 months project. So Open Nebula is the coordinator, and the consortium is 10 partners. So with other 9 partners, we are implementing and executing this project. So we are almost close to the, let's say, mid-term, the interim period in a few months. And so we already started about the project and designing this framework for the Cloud-Edge Computing. You can go on the second slide where I will talk about what is the aim of the project and where we use AI. Mainly because this event is to talk about how AI can be used for cloud and which technologies can help in improving, for example, the cognitive cloud computing. So the main aim of Cognit is to look at this cloud edge continuum. So we go from considering all the resources that we can have going from the edge or the far edge, very close to where we have IoT edge devices that needs to execute functions, to execute workloads. So the Cognit is based on the concept of code offloading using a serverless paradigm. So the main aim is that from the application perspective, user perspective, we would like to use this serverless paradigm where the application doesn't have to take into consideration all the different ways to manage resources. Now, if we look just at one cloud provider, AWS or Google Cloud or one public cloud provider, they provide one way, for example, to run function as a service, right? They provide serverless framework. And they have their own API, their own framework, and so on. If we look at multiple clouds or even heterogeneous in the resources, like edge providers or telco providers, public providers, on-premise or data centers, and so on, private clouds, clearly this makes things even more complex. If I have to manage all the different layers that go from the far edge until the public cloud. Also, because I have to take into account that an application or the function can have different requirements according to what I need to do. So, for example, for some function, I have very low latency requirements. So the best would be to execute the function where the data, for example, is not generated, should be executed. Maybe there are some other tasks that maybe they do at aggregated levels of information that I can push to the cloud center. So the idea, first of all, is to build a framework that manages all the complexity that is behind the cloud edge continuum when we are considering heterogeneous resources. So, and there are even interoperability issues, there are security issues, and so on. So this is the first thing, is that we need to provide a framework that allow us to exploit all the resources that are along the cloud edge continuum. And the second point is how we can improve the management of these resources by using AI. So the core of the Cognit project is the brain of the framework is AI-enabled orchestrators that takes into account not only the requirements that comes from the different, let's say, edge devices or application at the edge, so in order to execute this function, but it takes into account all the complexity that comes from the different resources. Okay, so the main point is that we are working on having a monitoring system that can provide all the metrics, for example, related to infrastructure, to applications, metrics that we let's say we store in a monitoring system, and this matrix can be used by using AI approach in order, for example, to characterize the workload, and also to predict, for example, if we have time series, to predict future workloads. Okay, so the AI is used both for workload characterization, so we need to understand which kind of dimension in the cloud edge continuum is going to use. Now that goes from CPU to networks to latency and so on. In prediction, also trying to predict what would be the future workload, and so we can use approach that, for example, analyze time series mainly. Okay. So I will try to be, because maybe we are a bit late, I don't know, so let me just go very briefly about. So what we are going to provide is this function as a service serverless paradigm that can exploit all the resources along the cloud edge continuum. We are going to use also open source solution, like we provide this Open Nebula, some SUSE ecosystem tools and so on. And the other point is that we consider also security, energy efficiency heuristics, because we consider also the fact that we would like to optimize this workload also according to optimize also, for example, energy consumption. That is really important in order to have sustainability for this kind of thing. I will just very briefly say that we have 4 use cases that are about smart cities. This is led by the ASISA partners, that they are building this distributed intelligence system for transportation, where we are going to tackle the problem of prioritization within a city, like, for example, no emergency transportation or public transportation, especially in areas that are densely populated. We need to define priorities in order to allow transportation. The second one is about wildfire. The partner Nature 4.0 has built some IoT devices for wildfire detection. So we are going also here to use this framework in order to offload using some ML AI techniques to detect, for example, fire coming from cameras. The third one is about the energy. So here the 2 partners are Phoenix and Attende, and they are building this kind of distributed energy smart meters where they can run application at the edge and offloading, for example, also this in some decision-making algorithm based on MI and ML and AI. The last one is about cybersecurity, because in the cloud edge continuum, one of the issues are that we have more points when there can be attacks, especially at the edge. If we consider application when there are multiple connected IoT devices like vehicles, here CETIC and SUSE are collaborating on this project where we analyze, for example, anomaly detection using ML and federated ML AI. So we have ML AI both within the framework for orchestration of resources and managing the workloads according to objectives, and also in the use cases. Okay.
Good. Thank you, Marco. I think, if you don't mind,
sure.
Is that because I think I also want to give a few more minutes to CloudSkin as well, because then we have all the projects described. We have a wide view.
Sure.
We eat a little bit into the next session, but then at least everybody had time to present their interesting project. Yeah. So thank you very much, Marco. We go to CloudSkin. Mark Sanchez, please.
Good morning. So thank you for inviting us to participate in this webinar. So our project started last year, so it's like more or less in the half of the project. In a few months, we will have the mid-review project. So essentially, our project comprises like 12 partners. There are from people that is specialized from managing resource provisioning using AI. It could be, for instance, Barcelona Supercomputing Center, who will manage the AI part. We have also people that is more specialized in virtualization. And there are also, we have people that works a lot, let's say, in hardware acceleration. So we have, let's say, a project that tackles the whole spectrum, so, from the orchestration side up to the hardware resources. The thing in our project essentially is that we have like several problems that are available. One of those that is very important is about silos, because most of the projects, what is happening is that they are stitched to one specific technology, as I said in the beginning. So there are people that is basically working with containers, others are working with serverless functions, and so on and so forth. So our model is like to try to provide a common layer that can be executable across the whole Cloud-Edge continuum. So we are using something that is called WebAssembly containers that are extremely lightweight and allow us to run computations across the whole spectrum. Please go next slide, because there is a few remaining time. So our goal, as the rest of the projects in this call, is to develop a cognitive cloud that can exploit essentially the heterogeneous resources that we have available. So in our case, you can click everything, so it will be the complete slide because we don't have much time to discuss it. So our idea is like first to develop a general orchestrator. That orchestrator essentially is like a learning plane that is built using input from other orchestrators. In our case, we are not stitched to Kubernetes, for instance. We are like providing an APIs that can use to connect to different kinds of orchestration. The reason is quite simple, because Kubernetes could be very well for, let's say, fat edge servers, but could be not efficient for let's say, mobility use cases. So in the end, we're creating, let's say, an orchestrator using AI that is able to interact with the rest of the orchestrators that are below the layers. So that orchestrator has a pool of models, and this pool of models are applied depending on a specific use case. The main goal, because here is more about AI, the main goal of the orchestrator and at the level is for decision making. That could be task placement, to decide where to put a given task in a specific place. But also we have AI applied at the application level that is quite similar to another project that was presented before. So we use, for instance, we have a use case that is based on metabolomics, and this use case uses neural networks to identify or classify metabolites. So we are applying AI to orchestrate, again, AI inference to make it quite effective. One example to conclude, because I don't want to extend a lot, here you have like a circuit, and this illustrates a lot what is our focus, because in that scenario, we have like vehicles that go across a circuit, and we have like cameras that are connected using 5G technology. So the thing is that these resources are quite stringent, and we cannot just fully occupy with our computations all the available resources in the circuit, because it could be other companies that at the same time are using the same resources. It could be what's called multi-tenancy. So our focus here is that move the analytics application across the circuit following the car. So with that scenario, we have to predict the direction of the car to move at the right time the analytics applications to another server. So in this case, the AI is like predicting the time that the analytics application should migrate to another server. And this is done essentially to get input. This data is pre-processed at the edge, servers that are using 5G, and then they are moved to a central cloud for further processing. So this is like a clear example of what it's Cloud-Edge Continuum. So we are managing the whole spectrum. So okay, so you have much more questions. You have, and the slide is not essentially what I mean. It's so big, but I think they can get my email if you want to ask something.
Thank you very much. Thank you all for your presentations of your projects. They're all very interesting, and also the spectrum is very wide. cloud in where we use AI, how we use AI, which data we are using to train AI, where the data comes from. We all look at the edge to cloud continuum. Thank God we don't look at it anymore from a cloud to edge continuum, but we've turned it around. So that's very nice. We understand that the device and the end user are actually more important than the service provider. And my question is a little bit, when we start spreading AI all through the infrastructure and applications, how can we manage the training and deployment of them in a way that it's trustworthy, reliable, because all that AI is sitting all across the edge to cloud continuum, who's going to make sure that the traffic lights run the type of AI that you can trust, right? Is there going to be a certification or something like that? So it's amazing what we're building right now, but I'm already thinking at the next question is, how are we going to manage all this, train this? How do we know that the data that is being used is trustworthy to train the AI and all that kind of stuff? So that is basically my question for the next round. And I invite the presenters and speakers to share their opinions, right? So who can I give the floor first? I see some thinking time.
So maybe I can start.
Yes, please.
Okay, so in terms of, as explained in our case, we use AI as, let's say, the key role of optimizing, or let's hope we can optimize this notion of joint data compute network orchestration. So we bring a number of new parameters at different layers to the picture of orchestration, okay, and that also increases complexity. So, and of course, the type of AI we are using, okay, and the data sets that we rely, of course, they are prone to attacks or maybe prone to attacks, etc. So what we are trying to do in Codeco is that we are defining a methodology to analyze the resilience of AI and the governance. So this is a set of checklists, okay, that focus on, in particular, to give to the use cases and later. So right now we are going to release that in June, and that is more focused in our use cases. So we are going to test it in the use cases, which has different categories. So for instance, ethical aspects, so human interaction. So in our case, there is a project. One of the use cases relates with smart cities, and there are cameras monitoring. Okay, so the traffic and so on. And the idea is to do, so let's say, the usual offloading in a more clever way. So Codeco gets triggers and does that automatically based on the traffic affluency. And so in that case, for instance, just to give an example, there we may have some personal data, of course. I mean, we are not going to use it, but how should the use case avoid using it or having it? And so what we are creating is, as said, a strategy. So with checklists and steps that each use case needs to follow. So this is one aspect, okay? And the other is, of course, if an attack happens, if a situation happens, then what should we do? So, and this is going to be tested in the project. So right now, I said month 18 is the release of that. And then until the end of the project, so the next 18 months will be used to do validation and to analyze up to which point there is robustness and what happens in terms of governance.
And Rita, is that framework? It's open source, I guess, right? Because it's a pointer to the community. Okay, thank you very much. Very interesting.
So
thank you.
So the report is open. Okay, so will be public in June, but again, that is about the methodology. Okay, so initial tests only, and then Codeco has an experimentation framework that is being set. So where people can not just use the code, but actually do experiments already with additional tools. And we are going also to integrate that. So we don't have that yet, but for instance, for the detection of abnormal patterns, this is something we are integrating. And that is open source.
Okay, so part of the technology is proprietary, I guess.
No, everything is open source in Codeco. We really reached a very good point. We managed to convince the large companies, IBM, Siemens, etc. Everybody agreed with an open source. So the code is Apache 2.0, guys.
Wow, very nice. Well done. Who would like to comment again on on the question that we talked about? Ruta gave a very interesting already view on how to manage that, but who else in the project is also looking at that?
If I can,
yeah, sure.
Okay, so regarding for example, the deployment, the training of the AI. So as we said, we have this use case about cybersecurity, where also one of the main pillars of the Cognitive project is to have this secure and trustworthy computing environments, because when also you offload, for example, a function, or you would like to use some place where to execute even a function, it could be even an inference engine, it could be an ML inference engine. This should be somehow secure, because we need to understand if there is an attack or if something has changed in the environment. So we have this cybersecurity use case that is looking also how to have this federated learning in secure environments for the anomaly detection of vehicles, automated vehicles, where an attack can be pretty dangerous, right, for the vehicles themselves. Clearly, to make this, let's say, not only secure and trustworthy, but also the question was about fast, light, flexible. We are looking, if we look at this cloud edge or edge cloud continuum, let's say, it's a very highly distributed. So there are a lot of multiple dimensions. So having some centralized approach will not work. Also, if we take into account security and privacy, issue, because we cannot exchange data from one place to another place without considering this secure privacy issue, right? So I think this is a challenge in the sense that from one side, we need to understand how to make this flexible, especially in these highly distributed environments, and then having also tools that allow us to first check if we can trust when we get something back from an inference engine that could be related to a vehicle, could be related to a scheduling a task, and so on. I don't know if that was the question. That's my opinion. So we are looking into these matters also in the Cognit project. I don't know, there was a question from the team, but I don't know if I have to type or I can reply just quickly.
You mean there was another question?
Energy.
Yeah, I was wondering whether it was for your project or for the other project.
I think
I was not sure.
But I don't know if I have to type or I can reply very quickly.
No, you can reply here if you would like. Please also read the question, then I can...
The question was about this kind of energy efficiency heuristic in this project, and I think is about Cognit. So we are looking, so first of all, we have enhanced our monitoring system also with a tool that is an open source tool, Scaphandra, that comes from another project that allow us to measure energy metrics at infrastructure and application level. So this is something that we have integrated in our monitoring system that is also the baseline in order to understand the consumption and having this kind of measures. Clearly, what we are going to do is that the energy efficiency is looked from the AI orchestrator. So the orchestrator will try to optimize energy consumption using some approach that are called interference-aware scheduling, where we can looking even at other dimensions of the workload, like CPU or memory, I/O and I/O disk or network. This is the first approach that we have implemented. It can reduce the energy consumption and so improve the energy efficiency of the system. We are going to look to other approach. This is something that also there is a partner, Umea, that is looking into this, defining this energy-aware task scheduling. But yeah, the main point is the scheduling of the task or the workloads in such a way that according also to the other requirements that can come from an application or from, let's say, the execution of the function, we are looking into this. I hope this answer what was the question.
Okay, and there's your contact details as well, so they can also contact you for more details, of course.
Yeah.
Right.
Thank you.
Thank you very much, Marco, to also address that question. So let's go back maybe to the original question. I see Mark Sanchez I think you wanted to address that question that we had, right? Or not? Am I no? So the question about how the AI that sits across the edge to cloud continuum, how are we going to manage their, the training and make sure it's trustworthy, and what do we need to do? It's also distributed.
Yeah, in our case, it's distributed because the best strategy we have is like say a kind of federation scenario, because usually our use cases are like contain sensitive data. For instance, one of those use cases is called computer-assisted surgery. So the surgery it's like there is a surgery, the doctors are being assisted by an AI, let's say, and this information that is processing continuously video stream cannot leave the hospital, because you cannot take that data because it's very sensitive and move it around to the cloud. So in that case, the idea is like, okay, we have like you have the cognitive or the learning plane, but the learning plane trains things, but later this is moved and deployed in the edge, and it keeps within the edge boundaries. This is like a typical scenario. Other scenarios could be like part that is sensitive could be kept within the edge. We can, using again some preprocessing with AI, we can summarize the inputs to make it trustworthy, and these inputs could be moved to the learning plane. That could be, for instance, running a model or training a model in the cloud. But the thing is that data is filtered in the same place where it's coming from. So we don't have like taking data, moving around, and then, okay, maybe it's not trustworthy or not, because if they provide us good input, of course, the decision maker could be bad, but this could be the guilty of the original use case. So
do you have then a complete audit trail of your data, of your AI model when it got revised, new training data on it, etc.? So it's auditable. So in terms of when something goes wrong, we can find out who is liable, right? Or not?
Yeah, exactly. Because we have because if the data is not being provided correctly, the learning plane probably would detect this, because we will have like anomaly detection, and we'll notify again people from the edge. You have this AI is not working properly because you are providing input that deviates too much from the input that we have in the past. So we can detect it, because we have like this kind of federated model. Let's say that's part in the edge and this part, for instance, running also in the cloud. So
are you also abstracting, let's say, some standard to a standard for an audit trail of AI training, for example? I mean, is there something of a higher level learning that you can feed back to the community and that others can also start using in order to make their AI more auditable?
Oh, yeah. Okay. Yeah, we are working on that, because this is something that is managed by, we are from URB. There is another, and it's Barcelona Supercomputing Center is managing this, but it's like trying to develop an API using what they call data connectors. And with data connectors, they're collecting data, they move it theoretically to the cloud or another place where there is the training being performed. And the idea is that provide an API that people can ask for recommendations. So, and they just try to make it, I don't know, more a standard API, but it's something that we are ongoing. We don't have still well-defined the API. So, but all the project software is again open source. So as like the Codeco project. So when we have this well-developed, probably in the next half of the project, people can leverage it and use the different models, how to request recommendations and all the stuff.
Yeah, very nice. Thank you. Hui, I thought you were responding to the question. You intended to respond to the question as well. So how do we manage the AI and the trustworthiness and the training? What do you do in your project to kind of facilitate that?
Yeah, we can probably provide a complementary view on this. In our project, we consider explanation or explainability as a part of the trustworthiness. Of course, it doesn't solve the problem once for all. We still need a mechanism it doesn't avoid AI from making critical mistakes. But in some situations, the fact that we know why AI makes certain decisions, and we can make it to explain why and how they make decision, will help us as humans to understand what they are doing. And this kind of a common understanding is a way towards building the trust or building the alignment. An example.
Yeah, could you give an example how you capture that explainability and how you then can certify or qualify it? Because explainability is great, but if
yeah, that's a good question. We have some now. We just have some ideas, not a complete solution, but we are looking at two directions. One is the traceability. When the AI models are making some decisions, they must use some knowledge about either the historical performance of the system or some domain knowledge that they obtain. They either obtain from outside or they learn by themselves. Mm-hmm. So we want to find a way to force the AI to make the trace about what knowledge they used when they make the decisions. And the problem is that when you start collecting these traces, you will immediately get a lot of data, like logs or a huge amount of knowledge. So then we think that the generative AI could be helpful here if you provide this huge amount of data to them. And then the human stakeholders can start to query what exactly was the explanation. And this can be used based on this retrieval augmented generation. So based on your query, the large language model can generate the data processing or the data extraction queries among this huge amount of traces in order to generate a more human understandable explanation about what was happening beneath the AI made decisions.
Yeah.
So that's one direction. And the other direction is that we want to be able to create some challenges to the AI, especially to those AI that we use as a black box, like the large language model. It generates things, but we don't know how they generate these particular things. But the way we can do is to create some relevant questions to ask back to the generative AI. And if we can, by getting the answers of these relevant questions, we can be able to make a knowledge graph about how the AI managed to reach these kind of decisions. I have a simple example which is not relevant to computing continuum, but it's often used as an example about this. Let's say if we ask which country is Obama from, then the large language model may answer you that he's from the US, but there is no trace about what was the logic chain for it to reach this example. There must be some knowledge that it used, but we don't know which knowledge it used. We can ask similar questions like, what is Obama doing? He can probably say that he's the president of the United States. And then we can further ask, what is the relation between this job and the country? So by asking these relevant questions, then we can start to build an overview about how the AI made the conclusion. Yeah. So that's an open question about how you generate these questions and how you link the questions and answers together. So it's still open question to us.
Mm-hmm. Yeah, absolutely. And just as a teaser question, do you think that LLMs will become, let's say, smart enough when they're being tested? For example, I remember the diesel scandal in Europe, where the software was basically able to recognize when the car was being tested and would self-tune itself. Do you think that is possible though to build that in AI as well?
Yeah, I don't have any conclusion. I can only guess.
It will always be a cat and mouse game, I think.
Yes, yes. When you're getting more and more, you're getting smarter, it also learn to lie. That's something that we probably couldn't avoid.
Yeah,
but
exactly.
But it's the same like we build the trust between humans. We know we kind of assume that the human may lie, but at the same time we have strategies to create or to build the strategic conversations that can avoid this or even somehow build the trust regardless whether they would lie or not. I don't have a clear answer about how this can be done, but there are research in this direction.
Yeah. So maybe it was another project that was not. We didn't have time to present it here in the webinar, but we're also part of a number of projects, and one of the projects is called ACES, where we use a swarm intelligence to basically orchestrate not only the composable infrastructure hardware on the edge, but also do the orchestration of the workloads. And we put swarm intelligence first, and we use AI ML to try to understand the swarm, why it is behaving in a certain way, and how that relates to the parameter settings. And we hope, but we can tell you also only in a year and a half from now, whether it's possible actually to have certain metrics installed that allows you to understand how you can actually influence the swarm behavior in a way that the platform becomes energy efficient, has good bandwidth, etc. But it's a complex question. Yeah. But what I find interesting in the answers I heard so far, and that I would like to highlight, is actually now that we're developing so much AI, and I think what is beautiful to see is that we are looking really at building digital sovereignty, right? We look at distributed infrastructures, multi-tenancy, data from multiple sources, AI provided by various developers and organizations. Then the question is, okay, so but what are the rules in order to make this trustworthy? And I hear already in some of the projects we're looking at those aspects, and maybe I'm jumping the gun for the session that after 12 and 4 minutes, but one of the answers could be future projects should focus on that. So what are the rules and tools of the game in order to feed your AI or share your data in the digital sovereign economy in order to make it trustworthy, right? So maybe we should start doing something there. But okay, before we go to that session, we still have a couple of minutes. Is there anything you still want to share on let's say, AI training, model management, data management?
Just to let you know that there are some speakers with their hands raised to speak. Alexandros Nizamis.
I see it now. Sorry. Good. Alexandros, go ahead.
Yes,
please.
I would like just to elaborate a bit more with what we said. For example, as he refers to explainable AI, I think it's a nice way that can support a lot regarding the transparency part if we're checking from trustworthy AI. For example, in the project, what we're thinking to see is to try to present to developers or system administrators, etc., to present why some decision was done in this AI orchestrations that we have discussed so far. So in the end, which are the features that the AI orchestrator finally considers for training and for taking this decision. So we would like to see if really the energy consumption features was really taken into consideration, or if in the end we just go again only for the performance. So I think this type of the information is a type of the information that we would like to collect and present. There are a lot of libraries related to explainable AI that they do this, and the idea is to try to incorporate some of them and use them for supporting this transparency part of trustworthy AI. But also, as other people comment here, it's not only thinking for transparency. If we want to trust AI, also we should consider that AI will be always available, should be reliable, and so on. So I think we should also consider approaches, as we said, about federated learning that support both on privacy, but maybe also on the performance. Also, we can break down somehow complex AI systems to smaller ones for having some more flexible deployments. So all this containerization and microservices logic that I see in all projects, I think also apply if we want to have AI to be available and lightweight and so on. Maybe we should consider other techniques such as transfer learning, so we can use already pre-trained models from one case to another. This is near to federated approach, but it's not exactly the same. And I think also we should consider these part and not only the transparency part that we mainly discuss. So that was just a comment in addition to what we and other people said for me.
Perfect. Thank you, Alexandros. Maybe just a closing question from this session before we move on to the next one, where we look at the future, is from each of you. I find it AI is going so fast, the development is going so fast. And I think when you wrote your proposal and started your project, you kind of knew what kind of AI technologies you were going to pursue. But new technologies are basically being published almost, weekly, I would say. If you could add another or explore, suppose you would be able to get another, 300 or 400K to your budget to do some additional work on a specific type of AI, which one would you find interesting to investigate? And I'll go from top left to bottom right. So I start with Alexandros.
Okay, so for example, in our project, we didn't consider any kind, for example, of LLMs there. So we see that maybe they can fit so well with what we discussed now. Maybe we can have user queries that can support this functionalities of interpreting AI and maybe can give these answers to the end users, as we discussed now more about transparency. Or if not LLM, maybe we could also consider some kind of integration of AI capabilities directly into the edge networking devices. For example, we didn't consider if any AI can be uploaded to any switches, gateways, routers, or so on. And so also this would be an option. For me, at least these two areas maybe could be interesting and could be fit to our project that we didn't include them so far.
Absolutely. Thank you. Thank you, Alexandro. Marco.
Okay.
What would you choose?
For it will be the same as Alessandro said, but just to tell you, for the moment, as I said already before, we have considered this workload in the project, the workload characterization, where we used some PCA and let's say encoder-decoder approach for characterize the workloads for the application. So going from high dimensional space to very low dimensional, latent space, where we can, because we are looking mainly at time series along CPU, memory usage, or application specific metric. The second one is the prediction of time series, so that we are looking like some LSTM or some ARIMA or regression approach, this kind of things that allow us to improve the workload and the scheduling of the function. What we didn't consider is, let's say that for this anomaly detection logs, we can introduce some LLM that are now could be pretty useful. There are several approaches now for log analysis that allow us to know, for example, to have anomaly detection or to improve the insight within the log itself. So the interpretation of the log could be better using these large language models. That could be something that we can also explore in this project.
Thank you. Claudio, what would you choose?
Yeah, also for me, that's an easy choice. I would say simply LLM. We see some EdgeRace is a project that provides technology that will support AI. And at the time, generative AI was not such a huge wave as it is today. So it didn't fall into the design space of our solutions. We can still fit it in, but it was not there at day zero.
Yeah, and you would use it to support explainability probably, or to better understanding of your regular AI, right?
Well, yeah. Well, we have a different view, I think, from compared to that of the other projects on the split of responsibilities between technology and the use of AI. Meaning that we are trying to develop solutions that assist that the AI users can actually exploit for their purposes by trying to remain as abstract as possible. So what they want to use with their AI tasks is their own problem. I think that's a sort of safe choice from our point of view, because speaking for myself, I mean, I'm an engineer. I don't want to be blamed if some other guy does something with wrong with the AI model. I'm not AI expert myself, but I understand that at some point the line between technology and a use of AI becomes a bit blurred. So this is something that I guess will be discussed also in the upcoming part of the panel.
Yeah. Thank you very much, Claudio. Kui Song, what would you choose?
We are lucky that we are already looking at the large language model.
Yeah.
But if we have additional budget, we would like to look at the compliance of AI usage in the continuum, especially considering the AI Act from the Commission. So how this means to the use of AI in the computing continuum, since this is also a critical infrastructure now for the society.
Yeah, thank you. Mark, what would you do?
So again, I'm very inclined to LLMs, because I feel that if we have much more budget, for instance, imagine that we have like a AI model that decides, okay, this task should be run in a cluster with 5 machines. This means that somehow we have to provide the means to deploy that cluster, but using text generation that is being provided by LLMs, which automatically generate let's say the Docker files, all the stuff we need to deploy it automatically. So instead of using APIs that are for doing so, we can like have a way to tell to the LLM, please give us or write all the code that we need to deploy this new cluster and launch a computation. So this interesting part of automatic deployment, it could be very great. And it matches perfectly well with the Cloud-Edge Continuum, because in the end, one of the problems we have essentially is that we have AI, you have like several kind of orchestrators. Each orchestrator has a specific configuration file. So it's like sometimes we have just to rewrite the same kind of deployment multiple times because it's using different orchestrators. So maybe we can have like a way to say, write this deployment for that type of cluster, and this could be generated automatically. And then this is related again to your questions about trustworthiness. So then this could be also an interesting use case to see if LLMs are able to understand what we're saying and they're deploying correctly the dependencies and everything. So I think here it's a good fit for a project like this.
Yeah. Thank you, Mark. Georgios, what would you choose? What would you choose?
Yeah, sure. I was muted. Okay, first of all, of course, we have not included in our proposal LLMs, but as a future direction, we have a dashboard in order to have an interactive human-in-the-loop communication. And probably in this interaction with the middleware, for example, we have 3 different use cases. The first one is about manufacturing, the second one is about health, and the third one is about mobility. We have a scenario, let's say, about a medical practitioner that interacts with our dashboard, and probably an enhancement for this interaction in order to get the results, and also get feedback regarding probably also considering the explainability of the decision of this AI system. We can somehow adopt also LLM technologies. But of course, this is something that we did not include in our project. But we can. Okay. I think I have also one more question from the audience about the. Give me 1 minute to check again the question. Okay, about the bidding and auctioning comes from the multi-agent system and how this connected with the self-organization, which is one of our main objectives, the self-organization of the different devices existing in this computing continuum ecosystem. So we have these three main properties I said previously about the pricing, the bidding, and the auctioning properties, and each device somehow has a different approach. For example, we need for this 10 devices, or for the and about this bidding, the algorithms of the asymmetric multiplayer competitive games give the optional solution in order to have all the different systems
rated.
Yes.
So you can compare them.
Yes, yes. We have different levels, and according to this, the main consideration of Cognition project is about game theory. So this is about also considering three main aspects: the computing, in order to have without any problems a functional operation, of course, but also considering the energy optimization and the security aspect. And all these three levels, of course, I will not go into technical details, but these are the main theoretical aspects that also affects the result of this distribution, let's say.
Thank you. Thank you also for answering the question. Ruta, the final question to you: which AI technology would you explore or add to your portfolio to invest a little bit more time in? Had you had a little bit more budget?
Okay, so as said, we are focusing on decentralization and miniaturization. So LLMs don't have an explicit, or generative AI doesn't have an explicit role here. So if we had more budget, we could explore, let's say, for instance, one of the things we want to explore and are exploring is swarm learning, which has some weight in terms of design. Okay, may not fit all the scenarios that we have that are mobile, for instance, with cars, etc. Or with the mobile automated robots, okay, which are based on embedded devices such as Raspberry Pis, okay. And so we are still defining how to do this. Marl is an option. So LLMs could have a place, okay. So we discussed this. It's not in the project, and there is no intention during the lifetime of the project really to explore this. It could have a place, and possibly will have in future follow-ups of this project, okay. Related with experimentation framework that Codeco brings. So as said, we have the open source software, but we have also developed an experimentation framework, okay, that anybody can use. So to do immediate deployment of clusters and to use load generators, and all the Codeco components are expected to be there right there. Right now we have two linked, so the scheduler and what we call ACM, so the control plane. And the LLMs have a place there because that's like a centralized approach to generate, different environments and to do, let's say, to increase variability in the type of testing that we want to do. So that's where LLMs could have a place, okay, but not in my opinion, and at least other partners that are involved in the AI. In terms of far edge, okay, quite tricky to consider that at the current stage. Yeah. So we would like to prefer to really approach on this decentralization, which we think is important in IoT environments.
Yeah, I think across the whole continuum, edge to cloud, decentralization is key. We have now another session on edge system, the perspective on the value of data technologies the project. So we talked already a little bit about the importance of data, and there are 2 projects that Francesco Marudo is going to present that shed some light on data-relevant technologies that we're developing in those projects. Francesco, the floor is to you, please. You're muted.
Yeah, can you hear me?
That will help. Yeah.
Yes, sorry, it's my my microphone doesn't work. Hello, everybody. So I'm Francesco Muredo. I'm senior director in a think tank called the Lisbon Council, named after the Lisbon Agenda, where we work a lot on, let's say, technology, communication, and socio-economic impact of technology and policy impact. I will be brief so that we can leave space to further discussion. Discussion is extremely interesting. I will just present briefly 2 projects in which we are involved. Hopefully.
Slide share.
Yes, I'm trying to. Okay, can you see my screen?
Not yet. No.
1 second.
Okay, while you play, do you mind if I tell a little bit already about glaciation, the glaciation project? Probably he logged out and he logs in. Let's see. So the glaciation, oh, there he is.
Yes, sorry, my Zoom closed. Okay, so, okay, I see. Okay,
yeah.
Now we'll be able to.
Perfect. Yeah.
Sorry apologies for the inconvenience.
We can see the slides. Just flip.
Yes.
Okay, very good.
So I'm going to present briefly two projects that were funded under the call Data 0101, one in 2021 and the other one in 2022. So one is TEMA, trusted extremely precise mapping and prediction for emergency management. It's a project coordinated by the Aristotle University of Thessaloniki, and of course is on disaster management. So what are basically the problems, the issues that brought us to work on this project? So climate change, as we know, is basically adversely impacting European countries for what concerns, for instance, forest fires and flooding, and the impact of these events is basically costing $3 million of economic destruction and 1.3 million casualties. So from 1998 to 2017. And in Europe, there have been nearly 50 million in the more or less last 40 years affected by this kind of disasters, with a loss of 12 million per year. In that regard, new technologies like artificial intelligence, extendable AI, and AI and XR can help to solve basically natural disaster management problems, and they have a higher degree of maturity with respect to a few years ago. So what brought us here? Basically, the need for trustworthy information, so access to heterogeneous, accurate, and reliable data is, of course, crucial to take basically decisions, and especially for helping first responders and public protection for disaster relief. Transferability. So basically, the idea is to provide Cloud-Edge-IoT Computing infrastructure that offers basically transferability of services and products to other geographic region and disaster type. And also the idea to use data for scenario provision. So in order to improve the quality, precision, and the completeness of the provision in order to elaborate future strategies. So basically, the idea for the project is to develop technologies for facilitating NDM, so natural disaster management, exploiting artificial intelligence technologies. So the idea is to deliver a technical solutions that will provide a decision support system in disaster management in various geographical regions. So the objectives, as we said, is to develop an artificial intelligence-enabled natural disaster management platform that is validated basically in two big set of cases: forest fires and floods. So the idea is that the project also develops advanced augmented reality visualizations in order to basically provide interactive visualization that can be used also by non-technical personnel from the civil protections. We can basically skip and go to the results and benefits. So the idea for the key results, as we said, is produced real-time visual and social media analytics software, novel explainable AI algorithms for multimodal analysis, advanced federated analytics middleware for edge-to-cloud continuum paradigm, and basically software and visualization for managing forest fires. The idea is also to provide digital twins and geovisual analytics software in order to visualize basically maps of the territories that are affected, but also visualize what are basically the impact, the perspective impact of these disasters. And the project makes use of basically the edge to cloud paradigm. In fact, the idea is to develop a solution for the harmonization and sharing and use of data coming from heterogeneous sources in real time. And the solution will run because, you know, we are basically finishing the first year, so there is still a lot of ground to cover. The idea is to basically develop a solution that runs across the edge to cloud continuous, so that computation and storing are basically extended toward the edge in a federated manner. And the edge will be basically the various equipment of the emergency responses actor, and they will be distributed across locations and will be in mobile centers. So this is basically TEMA. Of course, I can provide you with more.
Francesco, for one quick question, you say something about middleware somewhere, I think 3 slides back, like something with data, let's say. Advanced federated analytic middleware for edge to cloud continuum paradigms. Is that open source?
Yes, it is open source. Yeah.
Very nice. Thank you. Glaciation.
Yes. Let's move to glaciation. Okay, 1 second. It's been a while that I haven't used
PowerPoint.
Not that I haven't used Zoom, so.
Okay. Well, you're better than me, so go ahead.
You can see the.
Yep.
Okay, so glaciation, green responsible privacy preserving data operations. So the project is coordinated by the Italian Ministry of Economic and Finance, but Fred Buning is basically the initiator of the technological idea behind the project. So it's
together with Dell, I need to say.
Together with Dell.
Absolutely.
And so what brought us to glaciation? So basically, citizens produce a massive amount of data, and we needed to ensure privacy and data ownership. Businesses, of course, gather and produce data, and at the edge, they store that data that should be stored, transferred, and analyzed across the network. And also, in this case, privacy-preserving technologies are paramount. And public administration, in particular, we are talking about basically data owned by the Italian Ministry of Economic and Finance, which basically manages the payment of the civil servants in Italy and also of all the basically providers. So we are talking about a huge amount of data on payments, but also data on benefits and so on and so forth. So this is a source of data that can be used. So the main idea is to develop a digital platform that increases operational performance and enhances energy efficiency. And so the idea is to basically use AI-powered optimization engines to improve privacy awareness and while reducing the environmental impact. So there are three main pilots. So Edge decentralized data management. So this pilot addresses the needs for resource efficiency and high privacy standards on a nationwide platform for human resources management. So this is basically the pilot owned by and promoted by the Italian Ministry of Economic and Finance. Second pilot is data-driven and energy-efficient manufacturing. This pilot addresses the need for resource efficiency, advanced data analytics of tagbots and cobots in basically in a digitalized smart manufacture. And the third one is privacy preserving cross-company analytics. So this pilot addresses basically the highest privacy standards while sharing data and analyzing data in a distributed architecture that spans across boundaries from different organizations. So the key outcomes that are expected in the project are the optimization of data movements and operations across the Cloud-Edge continuum, improve basically data transfer of operations and operations in order to have them environmental friendly, so consuming less energy basically, and privacy focused and privacy preserving. Keeping data closer to the source as possible in order to increase the speed and reduce latency, and basically improve the privacy and lowering the energy consumptions for data movement and operations. So this is basically the key outcomes and the key capabilities of the project. So the idea for the project is, of course, to support green transition from the digital point of view, so digital transformation, and also from the green point of view, so transition towards less impacting environmental operations, improvement from the energy and sustainability point of view, compliance with privacy regulation, integration of Edge and IoT. And in particular, also the cybersecurity point of view is important in order to basically support digital sovereignty in edge environments. And it's very important also that the project aims to address data center energy and sustainability concerns. So basically, this is GLACIATION. I give back the floor to Fred for discussion.
Thank you, Francesco. We are reaching the kind of the last phase of this webinar, where we are drawing conclusions. Maybe just to open the floor to every one of you, and Francesco will join as well on the conclusions. I think if we look at the various projects, and not only the projects here, but some of the projects that are not being presented here, or many of the projects that are not being presented here, we've just seen here the highlights. I must conclude that there's an immense value in the technologies that we're developing. I mean, I'm seriously impressed, and I read a lot of research papers. The amount and the diversity of technologies that we're developing to turn Europe into and empower them as a digital sovereign space, I think is is off for a good start, right? I think that would be my conclusion. But let's open the floor to others. Francesco, maybe you want to start off the drawing of conclusions. What would you say?
Yes. Okay. So from my point of view, of course, one of the topics that was touched during the discussion, which is very important, is the opening of data. And opening of data specifically, I mean, there is a kind of a line of projects of the European Commission that points towards the evaluation of the impact of opening data sets which are considered high-value data sets. For instance, data sets related to Earth observations, data sets related to statistics, company statistics, and so on and so forth. So the European Commission has basically understood and is kind of pushing the opening of data, especially public sector information or data, for instance, from cities, because as we said, artificial intelligence models are not very useful if we don't have data to train them. Yeah. And it is recognized also that all the paradigm of data space goes towards this direction. So the projects that want, for instance, to create data spaces for a city from data, like usage, for instance, is one of the projects in which we are involved, that is creating data spaces in which cities will provide their own data, in particular data related to environment and data related to basically air quality, to traffic, to temperature, to heat bubbles. So this is very important for future project. And another thing that is very important that is pushed is the combination of satellite data with open data that are collected basically by cities. In fact, the satellite data combined with cities are able to provide support for decision making, especially for what concerns the management of green areas, or basically they can provide data for training smart cities based on AI.
Yeah. Just to make one point about this, making data available, and I think we're opening up another discussion, I think, by doing this, is so a data economy is about monetizing data, right? It's great that the European Union enforces the availability of open data sets, great. But I think what still needs to be solved, and I don't see anyone doing that, is how do I monetize if I have a data set? How do I monetize when an AI model is being trained with my data set? And do I make any money of that? Or how does it work, right? That mechanism is a very tricky one. And it would be great if we could launch some initiatives there that try to figure that out. I mean, it doesn't have to be the golden solution, but we need to somehow tackle the elephant in the room, right? So that would be my recommendation in that area. I'll go to some of the other participants here in the webinar to draw conclusions. What are some of the conclusions that you drew during this webinar? What struck you as, oh, wow, that I didn't realize that? And I'll go random. I'll go from Claudio, please.
Well, I'm happy about the outcome of this panel, because I see that there is a clear trend if I look to the projects which are ongoing and the ones which have started more recently or are about to start, of increasing the complexity and the ambition of what the European companies can achieve altogether. So I'm happy on that side. I'm a bit afraid on the other side, because this increasing complexity, it will be difficult to handle and to make it in practice. Sometimes I have the feeling that maybe addressing an easier question in an efficient manner would be somehow more worthwhile than addressing a complex issue with a complex solution that maybe will be difficult to replicate. But in any case, I see that there are a lot of synergies, and the different projects they are all looking at the elephant from different angles, which gives me hope that it will be possible to at last take it down.
No, I fully agree. So the technological landscape is very broad and very deep. That creates complexity, but that's the beauty about doing this in a democratic way, right? And not by these large players that just take up all the market and everything. There's nothing left for other players. But yeah, to then make it coherent, move to some, to something useful for the whole European Union, that's going to be a challenge, absolutely. I go to Mark. What were your conclusions that you kind of drew during this webinar?
Yeah, well, I joined a little bit about what Claudio said, and I see a lot of intersection between the projects because there is a lot of technologies that are, let's say, leveraged by many of the projects, maybe in a different way, but I think that are quite common. And there is another trend that I would like to highlight is about decentralization. I mean, the idea of not keeping the AIs in the same place, but deploy them around to solve a specific problems. I see it more or less in the big picture of all the projects. I think that it's very interesting. And the other aspect that I think it's vital, it's about data, as Francesco said. So I can ask a question to Francesco very quickly, or
yeah,
not?
sure, yeah, of course.
Because when you try to predict or the floods and the fires, what's about the data? So you are using something historical data, how you can predict that, because an emergency is something that happens suddenly and you utter the feedback you can, because it's a difficult use case, I think.
Yeah, it's very difficult. So we are using historical data for the prediction. Of course, I mean, basically the two pilots, at least on the forest fires, the ones that I know better, are in Sardinia, Italy, and in Aragon. So there is a long-term series, let's say, that can be used for this kind of analysis. But yes, we are using historical data that are combined basically with the data that will be collected through IoT in the forest, related to temperature, related to humidity, that also help to figure out.
Okay, thank you.
Maybe to comment a little bit on Mark, what I like about what you say, data is basically fluent, right? So fluent and we still call it edge to cloud continuum, but basically cloud is being referred to often as these big cloud providers, right? But actually it's all about round trip, right? Because it's from edge to edge. It's an end-to-end service. And I mean, in the cloud, nobody's living to be serviced. It's all about the edge. There's an edge device, there's another edge device. They collaborate together or they feed on each other with data. So, and in that space, that's where we need to manage the data and the AI to have it transparent and trustworthy, and it needs to flow and shorten and make the round trip as efficient as possible. And I think I agree with you that is still something that needs more research, let's say, or more progression. But there's some technologies in the projects that are luckily looking at that. I go to Hugh Song. What are some of the conclusions you draw from this webinar?
I wouldn't say conclusion, but for myself, I'm glad to see that many of us in this room has interest in large language models. And I would see it as a potential joint point that if we keep discussing or talking on how large language models can be combined with the different AIs we already plan to use for the continuum, there will be interesting ideas popping up. And I'm looking forward to that.
Thank you very much. Alexandros, what would you draw as conclusions from this webinar?
I think that altogether somehow we bring together a kind of common tools that can be applied, such as data, such as AI, explainable and trustworthy AI, these cloud edge technologies, etc. And all these tools have, I think, some common pillars or objectives for all of us. That is to promote some kind of efficiency, agility, trustworthiness, and environmental friendliness to the whole compute continuum and in general, maybe in the software engineering landscape, let's say. So for me, this is a kind of a summary that we have common tools, we have common target in all these projects, and I think this is for me one of the conclusions for today, that there is this kind of alignment with a common target for all of us, and the same stuff and same toys, let's say, to play and try to deliver.
Yeah, and it's rich. At the same time, we also try to do it. Everybody tries to do it in a similar way, but also in a different way. So we can compare some of the solutions we are going to find out there, which I think is very great. Rita, I'm going to come to you, please. What are some of the conclusions you draw from this webinar?
So first of all, it was good to hear. So some of the projects I already know because we work and try to cooperate a little bit more. Okay, like for instance, Cognifog. The others we have been in touch, but not so much. So it's good to understand the evolution and to see that we have common points towards decentralization, towards energy efficiency by design. So not just measures, but actually integration of mechanisms that can improve that. It's also good to see the different approaches, okay? The serverless approaches, looking into hardware, people focusing on LLMs, etc. I would say that what for the future, okay, what would be also interesting would be to understand how we all are doing experimentation. We spoke about data sets, which is absolutely the must, but there's more than that, right? So we are speaking about Cloud-Edge-IoT orchestration, and we are speaking about use cases that we all know are very hard to set, have problems when you go to the operational environments, etc. So it would be good to understand what can we do in Europe in terms of experimentation like we did before, and we are doing, okay, for routing with one lab, with Fed for Fire, and a lot of other things. So, and these we are missing in the CEI spectrum. So data sets, but also experimentation frameworks and test beds that we can use in large scale to mimic really what we have in the edge to cloud IoT continuum across the world.
Could you give so experimentation? In my understanding, I thought we're experimenting in these in the projects that we have. So what would you see then? What would you like to see more? Can you explain?
When we go to federated clusters, right, we are working with the internet structure, a complex system, multi-tier, autonomous systems. So what we call edge to cloud continuum needs an alignment, okay, to all these orchestration parts. It's not just about nodes. It's actually about the internet as a complex system. And we have a few initiatives, okay, again, EdgeNet is one of them, okay, led by Lip6, so Timur Friedman, that possibly so started in a project, okay, now is a bit dormant, has around 40 to 50 nodes. Federated cluster operation is still not completely good. So we would need, in order really to understand if this orchestration can work, right? Because we are making it more flexible, but also more complex, we would need large scale test beds. Like we have, for example, reference is one lab, okay, that we use for the routing and network management aspects, but we can't use for all these aspects of the orchestration in edge cloud IoT, okay, with AI and large models. So it would be great to try to understand if the projects could use something common and open.
Yeah, I understand. That requires real large investments, right? And really large projects. Yeah, it's true. I mean, if we want to be globally being seen as how must I say it, as a serious player, we need to build serious large infrastructures. Yeah, I fully agree. Who did I miss? Marco? I missed you. No conclusions.
Yeah, I will be very quick now. First of all, thank for this for the organization of this webinar. Pretty useful. Also, see all different So we are working using technologies like AI, cloud, but from different point of views. Also with different approach that can bring multiple output results, maybe good results for the to have very European based also technologies, as I would say, and where multiple also actors can participate, as you said. So we don't have to rely only on very big players also in this kind of the sector. So the first thing about data, yes, that's important because we really need that in order to do experimentation if we would like to improve AI and the machine learning models. Without data, we cannot do so much. So that's a really important point. And we should understand how also do that, right? Because we have some public data set that we can use. That, for example, in Cognit, we have a partner set up some emulation environment where we can have some connectors to some public data set or some internal data set or synthetic data set that would be also very useful, right? Especially in the context, I don't know, of the orchestration of tasks where we are looking at some standard, for example, dimension like CPU memory, just to give. Other conclusion, well, I think we live in a very interesting period. Maybe AI, this will be something that we are going to deal with in the next years, and that allow us also in Europe to maybe to build very interesting technologies that can be used, for example, in the Cloud-Edge Continuum and then used within different vertical segments. That would be that would be very good that we are going from experimentation to the usage of these technologies within sectors within business.
Thank you very much, Marco. I think one more thing that you mentioned it for the first time actually with connectors. I mean, they're fundamentally important, right? When we talk about interoperability, we need to have basically libraries of connectors that we can use that connect to data sets and all data spaces and all those tools.
Yeah, the point is also is that having every system can have its own follow its own standards. So we have some standardization in technologies. Look at the logs. We can have, but yeah, if we look at application specific, I don't know, metric. Yeah, everyone has maybe his own. So we need also this interoperability that can come from even connectors or
Thank you.
Standard can help.
So looking at the time, we're 5 minutes late, but I think it was worth it to have these discussions, absolutely, in the presentations. So I would like to thank you all for your presence, for your presentations, for being here and having this lively discussion. Georgios?
Yes, I think you forgot me.
I forgot you. I was pressured for times. They were already calling me for another meeting, so I apologize.
That one sentence.
Your conclusions.
Of course, I totally agree with all the previous speakers about the need for data, the interoperability of our solutions, and of course the explosion of LLMs that have power and are a very trendy topic nowadays. But I'd like to highlight another aspect. What about exploitation of our solution? Of course, we are participating in different maturity levels regarding RIA or EA. But our solutions, how close are to the industry? What is the social and economic impact of this project related to AI? How close we are to have a solution that, of course, after some adaptation, can be truly adopted by an industry? Are we close enough, or here we are only doing research?
Thank you for making that point, Georgios, because it's always surprising how just before you close the door, somebody comes with the the $1 million question, right? Which is, how close are we to exploitation and really pushing it into the market? And I fully agree on that. I once did a study in comparing the venture capital system in the US and in Europe, in stimulating startups and building stuff. It's a different. We live in a different world in Europe. So we have to rely on large industries taking smaller companies by the hand, not eating them. Well, that happens also, but taking them by the hand. And, the SMEs are the big companies of the future. And somehow we need to get them more involved in the game, give them more responsibility. And yes, many will fail, right? But it's the only way to get there. And I think start small. And I think we need the large companies to basically say, okay, small company, come here. I know a few other SMEs who are also a small SME who get the opportunity to work for these large companies and implement some of their technologies, that's the way to go. So thank you very much for that. With that final conclusion, I would like to close this webinar. I thank you again all for being here and spending your time. I thank Francesco also. I thank Martel for organizing this webinar and facilitating it. And of course, we thank the European Commission for financing our projects, and we hope to deliver more value now and in the future. Thank you all, and hope to see you more in the future. Bye-bye.
Thank you.
Bye-bye. Bye-bye.
Bye-bye.